the following groups, we're going to place the atoms and or ions in order of decreasing size. Let's do it. A, we don't need a periodic table because they're all forms of copper. So what do you think? As you remove electrons, what happens to the size? What do you think? As you remove electrons, the cations are going to get smaller, or going to get smaller than the parent neutral atom. The more electrons you remove, the smaller it's going to get. The reason is every time you remove an electron, there's less electron repulsion, and then there's also fewer electrons getting more of that nuclear charge. All right, let's go on to B. Now this one, we'll need our periodic table, nickel, palladium, and platinum all on top of each other there, so that makes it easy. As you go down the periodic table, these are going to get larger because there's just more energy levels and shielding. So platinum is the largest, followed by palladium, followed by nickel. All right, oxygen. This is the opposite reason, the anions. So what do you think? When you're gaining electrons, do atoms get bigger or smaller? When you're gaining electrons, the atom's going to get bigger, or the ions, because you're gaining electrons. And the reason is the opposite of the cations. When you're adding electrons, you get more electron repulsion, so the atom's going to puff up. And not only that, you have more electrons that have to share that same nuclear charge is what is attracting them. So the oxide 2 negative is going to be the largest, followed by the 1 negative, followed by the neutral oxygen. All right, let's go on to D. Yeah. I'll be honest with you, GD. I don't even have that. All right, hold on. All right, I rarely use these, so I don't even copy them over. So there's lanthanum, and I think it was europium. It's right there in GD, I remember. All right, what was the last one? Ytterbium, terbium, all discovered in, I think it was Sweden, same place. All right, that's not too bad. I'm going to move this guy down here with in the same row as the others. So when you're going across the periodic table, remember your periodic trends? As you go left to right on the periodic table, you get relatively the same amount of shielding. Now they're in different sublevels, but more or less they don't shield each other, the electrons on the outside. So it's going to be the nuclear charge that is the trend. So as you have more and more nuclear charge pulling those electrons in, the atoms generally, now there's hiccups of course, but generally get smaller as you go to the right. So let's go left to right. Wait, it's already written left to right. That's nice. Europium. I ain't gonna try to say GD. Alright, and ytterbium. 3 plus. Alright, last one. What haven't we used? Let's go dark blue. Alright, tellurium is over here. Now the charges are different. Yeah. Okay. Well, hold on. Looks like they're all isoelectronic to each other. That makes it easy. So tellurium gaining 2 electrons is going to be isoelectronic with xenon, and iodine gaining 1 is also. Yes. Here we go. Cesium losing 1 is going to have 54 electrons, and barium losing 2 is going to have 54 electrons, and this guy I need to put back maybe. And lanthanum losing 3. They all are isoelectronic. They all have the 54 electrons. Whew. That's not too bad. If they all have the same number of electrons, It's the number of protons, right? So as you have more protons, what do you think? They're going to be bigger or smaller? All right, well, I hope you said the smaller because protons attract electrons. All right, so which one, what are we going here? Decreasing size, I think it says. All right, so the biggest one is going to be tellurium because that has the fewest number of protons. And this is right in order too, again. All right, that's the answer right there. Oh, let me make sure so I don't have to redo this. Yeah, good.